everyone, welcome to Sir Ranran's Math Tutorial, where learning math is made easy. Alright, so today we have a new lesson actually that is to be discussed, and it is the discriminant and nature of roots of quadratic equations, since we are done already with solving quadratic equations using the different methods. Okay, so let's not waste time. Let's talk about discriminant and the nature of roots now. First, let's try to define what is discriminant. The discriminant is used to determine the nature of roots of quadratic equations, and is given by the formula d is equal to b squared minus 4ac. Okay, as you can see, b squared minus 4ac is just part of the quadratic formula. So we're not getting away actually. So b squared minus 4ac is just here. Then, why do we need to solve the discriminant? Okay, accordingly, we can solve, if we are to solve the discriminant, we can tell or determine the nature of roots of a given quadratic equation. Okay, so there are three conditions that we need to remember upon solving the discriminant, so we can tell or determine the nature of roots. First, when the discriminant is greater than 0, so b squared minus 4ac is greater than 0, it means that upon solving it, the discriminant is positive, the result is positive, and it might occur that the discriminant is a perfect square or not a perfect square, but both are positive. These are the two situations that might occur. When you solve the discriminant and it's positive, it could be a perfect square and it could be a not perfect square. Okay, so if it's a perfect square like 1, 4, 9, 16, so on, what is the nature of roots upon knowing that it's a perfect square? So you can tell the nature of roots of that equation has two unequal, or you may say has two distinct rational real roots. Rational when it's a perfect square. Again, if it's a perfect square, the equation has two unequal, or you may say the equation has two distinct rational real roots. Okay, what about if it's not a perfect square? It is still positive, not a perfect square like 2, 3, 5, 7, so on. So you can tell the nature that it's the equation. The equation has two unequal, or the equation has two distinct irrational real roots. I-insert mo lang itong irrational doon sa distinct or after sa unequal. Okay, the equation has two unequal irrational real roots, or you may say the equation has two distinct irrational real roots. The same with when it's a perfect square. Okay, that is the first condition. I hope you get it. Let's proceed to second condition. Upon solving the discriminant b squared minus 4ac, it's equal to 0. Alright, it's equal to 0, so the value is 0 upon solving it. So you can tell that the equation has two equal real roots. Again, has two equal real roots. Okay, so that's the nature. What if b squared minus 4ac is less than 0? That means upon solving it, you have an answer that the discriminant is negative. Example, negative 1, negative 2, negative 3, negative 4, so on. So what is the nature of the roots of that equation? So you can say that the equation has no real roots, or you may say the equation has imaginary the roots are imaginary complex. Okay, the roots are imaginary complex numbers. Okay, or you may say that no real roots. It's an or, so therefore you choose one from these two. Okay, but they're just the same, their meaning are the same. Imaginary complex numbers are not real roots. Okay, so that's it. So we can have examples so that we will understand better. Here is an example of quadratic equation, and for example, you are asked to tell the nature of the roots of this quadratic equation. So what will you do? Of course, you have to choose the discriminant formula. But before anything else, you need to identify first the values of a, b, c, because these are very important here. So what is our a in this equation? You know that it's a 1, right? A 1. Following, as you can recall, our standard form of the quadratic formula, equation is ax squared plus bx plus c is equal to 0. So we're gonna find these three numbers. So for this example, we have a is equal to 1, and then b is equal to 5, and you will notice that there's no c constant. Third term, yeah, the constant, so it's a 0. You can place 0. Then you are ready to solve it, the discriminant. So the discriminant is equal to b squared minus 4ac. Alright, so substitute the values. B is negative 5, so you have negative 5 squared minus 4 times your a is 1 and your c is 0. And so you're going to simplify it. Negative 5 squared is 25 positive. So minus 4 times 1 times 0 is a 0. Alright, so that means your discriminant is 25. As you can see, your discriminant is a perfect square. And it's a perfect square. So you can tell now the nature of roots. When it's a perfect square, what is the nature? So the nature of the roots, so you write here, nature of roots of that equation given is the equation. Okay, the equation has two unequal or distinct. If you are going to use the word distinct, two unequal rational. Okay, rational real. Okay, roots. Ayan. The equation has two unequal rational roots, or you say the equation has two distinct rational real roots. And that's your answer for that equation. Okay, next. 2x squared plus 5x plus 1 is equal to 0. Alright, so we'll do the same. A is equal to 2. B here is 5. We have already C here, which is 1. Now, ready to solve, no? Ready to solve, that's a D. We will now try to solve the discriminant. So D is equal to B squared minus 4AC. Then substitute the values you got. For B, that's a 5. So 5 squared minus 4. Your A is 2. And your C is 1. Then simplify. 5 squared is 25 minus 4 times 2 times 1 is an 8. Okay, your D therefore is 17. Am I right? 17. Yeah, 25 minus 8 is 17. Yeah. So you can, 17 is positive but not a perfect square. Alright. So it's different from the first example. It's not a perfect square. So what is the nature of roots? Okay, what is the nature of the roots of this equation? So you say the equation, okay, has two unequal but irrational real roots. So you see the difference. So in the previous example, rational. This time it's not perfect square, irrational. That's the only difference between the two examples. Now, okay, I hope you get it. Let's have another example. X squared plus 2x plus 1 equals 0. So again, determine your A, B, and then your C, which is also 1. Okay, 1 here, the numerical coefficient of x squared. Alright, so D, your discriminant formula, again, and then substitute the value of b, which is 2, so 2 squared minus 4 times a, which is 1, times c, which is also 1. So you have here 2 squared is actually 4. 4 times 1 times 1 is also 4. So d is a 4 minus 4, therefore it's a 0. Remember, if d is a 0, right, you can tell the nature of roots now. What is the nature of roots of this example? So you may say the equation has to equal real, alright, real roots. Ayan. So 2 equal real roots. This is the nature of roots of this equation. Okay, I hope you get it. That happens when it's 0, when your discriminant is 0. Now let's come to the next example. 3x squared plus 3x plus 1 is equal to 0. So the same, you're going to have a is equal to 3, b is equal to 3 also, and your c is equal to 1. So discriminant is equal to b squared minus 4ac. So you will say b squared is a 3 squared minus 4 times, okay, minus 4 times, what is your a? It's a 3. What is your c? It's a 1. So that becomes 3 squared is a 9, and you have 4 times 3, 12, times 1, it's a 12. So d is equal to 9 minus 12 is a negative 3. You see? Negative. So it's negative. When it's a negative, what is the nature of roots? Okay, what is the nature of roots? You can tell that the equation has no real roots. And has no real roots. So you may say the equation has imaginary complex numbers, which are the roots. You know, which are the roots actually, supposedly, but complex lang siya. But the exact answer, you may say the equation has no real roots, or not real. When we say not real roots or not real roots, that's imaginary complex. So it's up to you. What word are you going to use? Ayun. If you want to prove, try to check by solving. For example, we'll try this one. We will solve the roots, and let's try to check if it's really 2 equal real roots. Okay, we'll try to solve x squared plus 2x plus 1. Okay, check. This is how you check this. Okay, say x squared plus 2x plus 1. You're going to factor first, right? When we solve the roots, we have to factor, or you may use the quadratic formula, or you may use the completing of the squares. Alright, so I'm just going to make use of factoring. So 1 factors of 1, that becomes 2. Obviously, you have x plus 1, another x plus 1 equals 0. Because 1 times 1 is 1, 1 plus 1 is 2, correct? So next, you have already your factors. You can equate both to 0 to solve for x. So another x minus x plus 1 is equal to 0. So here you have first x is equal to transpose, that's negative 1. Here you have x transpose negative 1. You see, the roots are the same. Okay, the roots are the same. The equation has 2 equal real roots. Okay, that's how you check, huh? If you want to check, just like your answer here, that the equation has no real roots, you solve it. And the best method to use is quadratic formula if you want to make it faster. Okay, and then you will find out, oh, there's no real roots. And that's it. I hope you get it now. If you are still a little confused, you may visit the video and review it again. Alright? So that's it. Thank you so much. I'd like to say thank you to our new subscribers like this one just to subscribe recently. Shinomiya, I don't know the real name of this one. But I'd like also to have this one. Special thanks to the following. Joshua Dagasuhan, Yushan Angelo Lim, Vince Lidon Makalam, Alex Randeray Aquino, Ayesha Zaiza, Bahian Kizaya, May Banaan, Catrice Isabel Karanatan, Faith Dimafilis, Lourdes Gabriel Emino, Maria Nathany Gundran, Mariel Jean Lumamba, Krisha Junel Pamay, Abigail Quintas, and Mary Nicole Karine Saragusa. I love you all. Nagmamahal, Sir Remy. That's it. Thank you so much. That's it. Bye-bye.